Okay, so next question is 8. So determine the force in each member of the truss uh, system in terms of the external loading, and state if the members are in tension or compression. Now we are given a truss system, as you see. It is pin supported with a pin to a wall or some ground at point A, and there exists a slider at point C, and we have two forces acting at point D and B. The force at point B is horizontal and force at point D is vertical. The truss system is made of 5 members. Distances are given. From A to D it is A, D to C it is A again, and point D is from point D to C, or point D to A is 1/4A, and from B to D is 3/4A. So from B to C it is A as well. So we are asked for the loading in the members. Now let's draw the free body diagram. Certainly at support A, the motion of the system is restricted in two directions. They are vertical and horizontal. So vertical and horizontal motions are restricted. But of course, the structure can easily rotate around A. As a result, there is no reaction moment at point A. There are two forces, support reactions, at point A. And in fact, at point C, again, only the vertical motion is restricted. As a result, horizontal motion is not restricted, and it can again rotate around C. And this basically means that we have only vertical component of the support reaction of at point C. Okay, so these are the support reactions, but first thing that we need to do is to draw the free body diagram. Again, I can choose any direction as coordinate, reference coordinate, and certainly I prefer to write horizontal axis as x coordinate and vertical axis as y coordinate. So let me draw it. So this is my x coordinate and this is my y coordinate. Okay, now next thing is I can choose the support reactions in any directions, and in fact now I decide to choose x in negative direction at point A and y in negative direction at point Y. Certainly I decide to choose the support reaction at C in negative y direction. You can choose any direction, there is no restriction about it. And first thing is to find the support reactions. Now I have 3 unknowns, and in fact from the equilibrium equations I have 3 equations, and I can easily find each support reaction in this problem. I prefer to take the moment with respect to point A, as you see. So sum of the moments with respect to point A has to be equal to 0. Now I assume that the clockwise direction is positive. So FCY multiplied by 2A, so 1A is here and 1A is here, plus P multiplied by A, this is P, this is the force at point B, and plus P multiplied by A. So from here, I can easily say that FCY is equal to minus P. So that is the support reaction. Now, sum of the forces in x direction has to be equal to 0. From here, I can easily say that Fax is equal to P, because in x direction I have only Fax, and this force does not contribute. Now, next equilibrium equation is sum of the forces in y direction has to be equal to 0. From here, Fay plus Fcy plus P is equal to 0. I omit the negative sign here because they all have the same direction. So no problem about that. Okay. Now, if you do the calculation, you already know the Fcy. Fcy is equal to minus P. From here, I can easily say that Fay is equal to 0, because this cancels this. Okay, now I find the support reactions. Fcy is equal to minus P, Fax is equal to P, and Fay is equal to 0. Next step is to number the members, truss elements. Again, I can number them in different ways. It's not a problem. So from member from A to B, I say that it's 1. Member from A to D, it is 2. From B to D, it is 3. And from B to C, it is 4. And D to C, it is 5. And of course, there is an angle from between the member A to D to the horizontal axis, and I say that it is phi, as you see here. Now, we will apply method of joints now. So I will begin from joint A. Now, joint A, in joint A, I have Fax. Remember that Fay is equal to 0. So I have F1 and F2. First thing is, F1 makes an angle of 45 degrees, but F2 makes an angle of phi. We can easily calculate the angle phi here. Sine phi is 1 over square root of 17, and cosine phi is 4 over square root of 17. So first, sum of the forces in x direction has to be equal to 0. This basically means that F1 multiplied by cosine 45, which is square root divided by 2, plus F2 for square root of 17, so it is cosine, minus Fax is equal to 0. This is our first equation. Now, let's write the equilibrium equation in y direction. So F1 square root of 2 divided by 2 plus F2 sine phi, that is 1 over square root of 17, has to be equal to 0. I don't have any other force in y direction. From here, I can easily say that F1 is equal to minus 2 divided by square root of 34. That's okay. Now, from the first equation, from this expression, I take this expression and I submit F1, and I write F1 by means of F2 by using this equation. As a result, from these two, I can easily find, I can write this equation, which is sum of the forces in x direction has to be equal to 0 by means of F2. and that will give me minus f2 divided by square root of 17 plus 4f2 square root of 17 minus p. From here, I can easily calculate the f2. So 3f2 divided by square root of 17 is equal to p. And from there, f2 is square root of 17 divided by 3 multiplied by p. This is f2, and f1 is sorry, just a moment. I have to move this line. Okay, so f1 is minus square root of 2 divided by 3p. Okay, so these are the equation values for the f1 and f2. Now I find the forces in f1 and f2 by means of p. Certainly I can easily say that f2 is tension and f1 is compression because it's negative. Now let's look at the joint B. In joint B, I have three forces, F1, F3, and F4. We have already calculated the value of F1. Therefore, we have two unknowns at this joint, which are F3 and F4. Again, I have two equilibrium equations. First, sum of the forces in x direction has to be equal to 0. From here, I can easily say that P plus F4 multiplied by cosine 45, because the member 4 makes an angle of 45 degrees, square root of divided by 2, square root of 2 divided by 2, minus F1 square root of 2 divided by 2. These are the force components in x direction. From here, I can calculate the F4 because I already know the value of F1. F4 is equal to F1 minus square root of 2p. And from there, I can calculate the value of F4, that is minus 4 square root of 2 divided by 3p. Now I know the value of F4. I can calculate the F3 from equilibrium in y direction. That is, in y direction, I have F1, F3, and F4. F3 plus square root of 2 divided by 2 F1 plus square root of 2 divided by 2 F4 is equal to 0 in y direction. From here, I can calculate the F3. It is minus square root of 2 divided by 2 multiplied by F1 plus F4. If I submit the values, what I'm going to get is the value for F3. So F3 is minus 10 divided by 6p. Obviously, I can say that F4 is compressive and F3 is compressive as well, since P is positive. Now, our last joint is joint D. Our next joint is joint D. So at joint D, we have member 2, 5, and 3 are connected, and we have an external load P. Now again, we will write some of the forces in x direction because we have already calculated the values for F3. And if we write the x components of the equation, we can easily say that F2 is equal to F5, and that is equal to square root of 17 divided by 3